Solve the trigonometric equation cosine of 2 theta equal 3 sine of theta minus 1. To solve a trigonometric equation in terms of theta is to isolate theta. In order to isolate theta, we need to combine like terms with the trigonometric functions, either sine or cosine or tangent, and so on. In this case, we have two trigonometric functions, cosine and sine. We need to find a way to rewrite them. We see that cosine of 2 theta can be rewritten as cosine squared theta minus sine squared theta using the double angle formula. The right hand side is still 3 sine of theta minus 1. There are two terms with sine and one term with cosine. It is more convenient to rewrite cosine in terms of sine. We use another trig identity, the Pythagorean identity. Cosine squared theta is 1 minus sine squared theta. And we bring down every single term left. The right hand side is still 3 sine of theta minus 1. This equation is equivalent to the previous equation, which is equivalent to the given equation. This equation now has only one trigonometric function, so we will zero this out. The left-hand side is a negative 2 sine squared theta plus 1. We move 3 sine theta to the left-hand side by subtracting the equation from both sides by 3 sine theta to get negative 3 sine theta on the left-hand side. And we move negative 1 to the left-hand side by adding 1 from both sides of the equation. Simplifying this, we have negative 2 sine squared theta minus 3 sine theta plus 2 equals 0. Since the leading term is negative, we multiply negative 1 to both sides of the equation to obtain 2 sine squared theta plus 3 sine theta minus 2 equals 0. This is a quadratic equation in terms of sine theta. To simplify the notation, we let u be sine theta and rewrite this equation. This equation can now be rewritten as 2u squared plus 3u minus 2 equals 0, and we solve for u. After we found u, we will need to do a back substitution and find theta. The only reason why we rewrite this equation in terms of u is to simplify the notation. We still need to find theta. To solve the quadratic equation, we either use the quadratic formula or factoring. Factoring is usually a preferred method if possible. We factor this quadratic as 2u minus 1 times u plus 2. We still need to double check this. 2u times u is 2u squared. 2u times 2 is 4u. 4u minus 1u is 3u. And negative 1 times 2 is negative 2. This is a zero product, so we can set each of the factor equal to 0. 2u minus 1 equals 0, or u plus 2 equals 0. 2u equals 1, or u equals a positive 1/2. U equals negative 2. But remember that this is not the solution. We still need to find theta. We do a back substitution where we replace u with sine of theta in each of these equations. For u equals negative 2, it is now sine of theta equals negative 2. We see that sine of theta is always between negative 1 and 1, so sine of theta can never be negative 2. With the second equation, there is no such theta. So we will work with the first equation, sine of theta equals 1/2. To solve this equation, we go to the unit circle. On the unit circle, sine of theta is defined to be the y-coordinate only on the unit circle, and we replace sine of theta with y. So this is y equals 1/2. So we draw a horizontal line, y equals 1/2. From the unit circle, the only angle that will give us the y-coordinate 1/2 or angles in the first quadrant and in the second quadrant, and they are pi over 6 and 5 pi over 6. These are the initial or the principal solution on the interval 0 to 2 pi. To obtain all solutions, we use the general formula theta equals pi over 6 plus 2k pi, because the period of sine is 2 pi. Theta equals 5 pi over 6 plus 2k pi, where k is an integer. K can be positive or negative. If k is positive, k equals 1 tells us to go around the unit circle counterclockwise one more rotation. K equal 2 tells us to go around the unit circle another rotation. If k is negative, then we would simply go around the unit circle clockwise. So we would obtain the negative solution. There are infinitely many solutions in this case.